So I'm currently in Japan, but I have a video for you anyway. This one is courtesy of BlitzCityDIY. She's doing a little guest video for me. This one features one of my favorite ICs, the MSGEQ7. So take a look. She's right there. It's going to come up now, and there'll be links in the description.
Hey, what's up? I'm Liz, and I have a YouTube channel called BlitzCityDIY. David Watts was kind enough to ask me to do a guest video on his channel. He's away. Thank you, David. I hope you have a great time in Japan. I can't wait to hear all about it. To distract us all from our jealousy that we have over David's trip, I have a project that involves an LED matrix, some IC chips, microcontrollers, and coding in CircuitPython. It's an audio spectrum display, and you can see it reacting to some music right now. Unfortunately, I can't play that music for you because it would cause a copyright strike, and I don't think David would be that excited to have a copyright strike on his channel. Basically, the matrix is running with a MAX7219 IC, which is a 24-pin LED driver. The pinout can be a little bit confusing between the MAX7219 and LED matrix, to the point that I actually have some diagrams I've made that make it a little bit easier to understand how they connect, and I also did a video on my channel about how they all go together as well. For the audio spectrum portion of the circuit, I'm using an MSGEQ7, which is a 7-band graphic equalizer display filter, which is one of my favorite ICs of all time. And that's actually on its own separate protoboard because it's from a project that I did previously. And then the brains of the operation is a Metro M4 board, which has a SAMD51 processor. Normally it's a little bit of an overkill. You can usually get away with an M0 with CircuitPython, but because the MAX7219 is communicating over SPI, I did notice a performance increase when I switched over to the M4 board. The M4 board is basically bridging the communication gap between the MSGEQ7 and the MAX7219 with its code. And speaking of the code, let's take a quick look at what's going on there. Recently, I've been really into CircuitPython because it's fun, it's constantly evolving with the devs over at Adafruit, and I can code stuff up really quickly. And what you're looking at right now is Mu, which is an IDE specifically made for using CircuitPython. You can upload stuff over USB to the boards really easily with it. It kind of transforms the whole experience of writing code in CircuitPython. The code that I wrote for this is actually based on some MicroPython code I found that was for a MicroBit board and an MSGEQ7. For those who don't know, a MicroBit is this dev board that's kind of for learning electronics, and it actually has a 5x5 LED matrix on the front, and that's what the code was utilizing. It was utilizing that matrix with the MSGEQ7. I don't really like to reinvent the wheel, especially with code, so I brought that MicroPython code in and just kind of adjusted some things, mainly with syntax, to make it fit into the CircuitPython world. I didn't really have to do much. And then I also adjusted the code so that instead of a 5x5 matrix, it was utilizing a 7x7 matrix. 7 is the magic number here because the MSGEQ7, as the name implies, is looking at 7 bands on the audio spectrum, and so it just makes things a lot easier to get things up and running properly if you kind of keep things in the frame of looking for 7 items, 7 LEDs to display 7 bands of audio data. The main thing was the math to get the output values to display correctly on the matrix, which basically came down to experimentation. The MSGEQ7 sends data through an analog input, and the maximum analog value in CircuitPython is 65,335, which is a very large and exciting number. So through some math, you can see here, and I also have the code posted up on GitHub if you want to try it out yourself. This makes it so that I can do an if-else statement for the rows of pixels, so that if the value goes over a certain threshold, it will light up the pixel in that row, creating the kind of up and down bar graph effect that you're seeing, but unfortunately not hearing because laws. Eventually, I want to adjust the code so that it's an 8x8 matrix filling up the whole area instead of just 7x7, but that will take some canoodling. It's just easier to get it up and running with 7x7. And eventually, I also want to do a custom PCB, make this like a little fun board where the matrix would be there reacting to music. Because, I mean, the matrices are so cute. You know, I think just on like a little boombox-shaped PCB, it could be really fun. But that's going to do it for this video. Thank you for watching. I hope that you enjoyed it. And thank you again to David for having me on as a guest video maker. I hope you have an amazing time in Japan, David. I'll send some reference links along to hopefully have down in the description for your reference in case you want to make your own little sound reactive LED matrix with CircuitPython. If you aren't subscribed to David, you totally should be. And my channel is BlitzCityDIY, where I do a lot of electronics projects just like this. I'd love to see you over there, and I hope you have an awesome day.